across the universe are doing the one thing stars do best. They're burning and they're broadcasting that light outward in every direction at once. And here's the part that should stop you cold. The overwhelming majority of that light produced by nuclear fire, light that took millions of years to fight its way out from a star's core to its surface, will travel forever through empty space and be seen by absolutely no one. Not now, not ever, not by any eye, any telescope, any mind that will ever exist. If a creator designed a universe meant to be witnessed, that creator built a machine that wastes almost everything it makes on a scale so large that the number of stars whose light actually reaches an observer isn't just small, it's statistically indistinguishable from zero. Start with something you already understand, because this gets stranger the more familiar it starts. You've probably heard that when you look up at a star, you're seeing light that left it years, centuries, sometimes thousands of years ago. That's true, and it's a fun fact most people file away and move on from, but sit with the actual mechanics of it for a second. A star doesn't send out one careful beam of light aimed at Earth. It radiates in every direction simultaneously, an expanding sphere of light growing outward at the fastest speed anything in this universe is allowed to travel. Picture a single star and picture that sphere of light expanding outward from it, getting larger and larger every second forever. Now picture how vanishingly tiny a single planet is compared to the surface area that ever its expanding sphere. Earth isn't catching some fair share of a star's light. Earth is an almost infinite decimally small target that the light happens to pass through purely by geometric accident, the way a single raindrop might happen to land on one specific blade of grass in an infinite field during a storm that covers the entire planet. Here's the question worth sitting with, because it's bigger than it first sounds. If a universe was built with intention, built as some traditions describe it to be a kind of witness to its creator's glory, or to give conscious beings something magnificent to look up at and wonder over, why would the actual physics of light distribution guarantee that? Almost none of it will ever be seen by anyone, anywhere at any point in cosmic history. You don't build a lighthouse and point it at empty ocean on purpose. You don't write a symphony and perform it to a silence you know in advance no one will ever enter. And yet, by the literal geometry of how light works, that's exactly the situation every star in the universe is. And all the time, everywhere, there's another layer to this worth, noticing before we even get to the scale of it, because it happens closer to home than any of the numbers ahead. The human eye itself is almost comically limited in what it can perceive of the light that does manage to arrive. Visible light, the narrow band of wavelengths your eyes can actually detect, makes up a tiny sliver of the full electromagnetic spectrum that stars actually emit. Stars pour out enormous amounts of energy as ultraviolet light, X-rays, infrared radiation, radio waves, all of it completely invisible to undead human vision when astronomers built instruments capable of seeing beyond that narrow, visible band, entire categories of the universe that had been sitting in plain sight for the whole of human history, suddenly became visible for first time. Vast clouds of star-forming gas, the faint afterglow of the early universe, entire galaxies too dim in visible light to register at all through a telescope, built only to see what we see. That means even the sliver of starlight that survives the journey to Earth and doesn't get lost to the geometry of empty space is, for almost all of human history, still invisible to the very eyes supposedly meant to witness it. The waste isn't only cosmic. Some of it is built directly into our own biology. The standard explanation people default to here is scale. The universe is simply so large and stars are so numerous that, of course, only a tiny fraction of the light gets seen. That's true, but it undersells just how staggering the actual numbers are. There are somewhere around 200 billion stars in our galaxy alone, and current estimates put the number of galaxies in the observable universe at somewhere around 2 trillion. Multiply those together, and you get a number of stars so large that human language barely has comfortable words for it. Something in the neighborhood of 10 to the 24th power, roughly the same order of magnitude as the number of grains of sand on every beach and desert on Earth, combined many times over. Every single one of those stars is radiating light in all directions every second, and the fraction of that total light output that will ever cross paths with a planet, let alone a planet with something alive on it, let alone a planet with something alive and conscious enough to look up and notice, is a number so close to zero that most calculators simply round it down to nothing. Try this thought experiment for a moment, because raw numbers like that are almost impossible to actually feel. Imagine standing on a beach at night, holding a single flashlight and switching it on, facing out toward the ocean. Almost none of that light will ever hit another person. It fans out into darkness, illuminates a patch of waves for a few seconds, and then continues on into empty night forever, having accomplished essentially nothing except existing. Now, imagine every grain of sand on that beach is itself a flashlight switched on permanently, all facing different directions, all doing the exact same thing. That's roughly the situation for the stars in a single galaxy. Now imagine that same beach, repeated across every beach and desert on Earth, every flashlight running the same way forever, and you're approaching something like the true scale of stars in the observable universe alone. Almost none of that light finds anyone, not because anything is wrong with the flashlights, because that is simply what light does when it's released into a mostly empty universe with almost nothing positioned to catch it. But here's where it gets stranger, because scale alone doesn't fully explain it. Even the tiny fraction of starlight that theoretically could reach an observer runs into a second deeper problem. Most of the universe is now moving away from us, faster than light itself can travel. That sentence sounds like it should be physically impossible. So let's slow down and actually unpack it, because this is one of the strangest and most underdized facts in modern cosmology. Nothing can travel through space faster than light. That part of Einstein's physics holds completely, no exceptions. But the universe isn't just full of things moving through space. Space itself is expanding, stretching in every direction all the time. And that stretching adds up differently at different scales. For anything close by, the effect is negligible. But at large, enough cosmic distances, the combined stretching of space between us and a distant galaxy can add up to more than the speed of light, even though nothing within that galaxy is actually moving faster than light locally. It's less like a rocket outracing a beam of light and more like 2 points drawn on a balloon's surface getting pulled apart faster and faster as the balloon itself inflates, even if neither point ever moves relative to the rubber directly beneath it. Astronomers call the boundary where this effect becomes total the cosmic event horizon, and any light emitted beyond it, no matter how bright the source, no matter how long the universe continues to exist, will never under any circumstances reach us. Not eventually, not with a big enough telescope, someday, never. Full stop is a matter of geometry, not technology. To put a real number on it, the portion of the universe we can even in principle ever observe is known as the observable universe, and its radius is roughly 46 billion light-year in every direction, giving it a total diameter of around 93 billion light-year. That number alone sounds enormous, and it is by any human measure. But Cosmologists studying the geometry of an expanding, accelerating universe strongly suspect that the full universe, the part beyond our observable bubble, is far larger than that, quite possibly many, many times larger, and in some models, infinite. If that's correct, then the 93 billion light-year sphere we can ever hope to study, measure, or witness across the entire future of any civilization that will ever exist here isn't a large sample of the universe. It's a rounding error, a single tide, pool's worth of water used to try to understand an ocean whose actual size we may never be able to determine because the rest of it is permanently, structurally sealed off from us by the same expanding geometry that's already stealing galaxies from view. Think about what that actually means to the light those stars are producing right now. It's not just improbable that we'll see, if we're a genuinely enormous portion of the universe, it is now physically, permanently, mathematically impossible for their light to ever reach any observer inside our observable bubble. No matter how much time passes, no matter how advanced anyone watching becomes, the design, if it is one, doesn't just make witnessing unlikely past a certain distance. It makes witnessing forbidden by the basic geometry of spacing itself. And here's the detail that turns this from strange into something almost eerie. The universe isn't just full of light we'll never see. It's actively, continuously, permanently losing light we could have seen. And the loss is accelerating because the expansion of the universe isn't just ongoing, it's speeding up, driven by something cosmologists call dark energy, a mysterious pressure, pushing space apart faster and faster. The more space there is to push, that means a cosmic event horizon isn't a fixed boundary sitting comfortably out in the distance. It's closing in an a sense on everything we can currently see. Galaxies that are visible to us today, that astronomers can point a telescope at right now and photograph will eventually cross beyond the point where their light can still reach us. And once they do, they'll fade from view forever. Not because they stop shining, but because the space between us and them will have stretched too fast for their light to ever catch up. There's a second, quieter kind of loneliness in the story, too. One that plays out the scale of a single galaxy rather than the whole cosmos. Even within our own Milky Way, home to somewhere around 200 billion stars, the distances between individual stars are so vast that light from one star's death, its final and often most dramatic release of energy, can travel for the entire remaining lifespan of the galaxy without ever crossing paths with a single planet capable of noticing. A star can live for billions of years, burn through its fuel, and in its final moments release more energy in a matter of seconds than it produced across its entire prior existence. An event we'd call a supernova if it happened somewhere we could see it, and that entire spectacular ending can unfold in a region of the galaxy with no witnesses whatsoever, simply because nothing happened to be close enough or aimed correctly to catch it. Astronomers have actually calculated roughly how this ends, and the picture it paints is almost unbearably lonely. Trillions of years from now, in an era so far beyond our present moment that our entire recorded history would be a rounding error by comparison. Virtually every other galaxy in the observable universe will have crossed that horizon and vanished from view, any civilization existing. Then looking up at what remains of the night sky would see only their own galaxy stars isolated in an ocean of pure black with no evidence whatsoever that billions of other galaxies had ever existed at all. They wouldn't even know to ask the question because every physical trace of the answer would already be permanently, irretrievably gone. We happen to exist at a specific privileged moment when a significant chunk of the universe is still visible. Every future observer, if any exist, will see strictly less than. We do forever with no way to recover what came before. There's an almost cruel irony sitting on top of all of this, and it belongs to us. Specifically, not the universe at large. Even the infinite decimal sliver of starlight that survives the entire journey, crossing unimaginable distances, avoiding the cosmic horizon, arriving at Earth still within the visible spectrum, runs into one final obstacle before it reaches a human eye. Us, roughly a third of the planet's population now lives under skies bright enough with artificial light pollution that the Milky Way, the very galaxy we live inside, is no longer visible to them at all. Cloud cover blocks it. Further, daylight erases it for half of every rotation. Add it all up, and the actual fraction of starlight that survives billions of years of cosmic travel only to be blocked in the last few miles by a street lamp or cloudy night is its own small, almost darkly comic layer of waste stacked directly on top of every cosmic layer already described. The universe loses almost all its light to geometry and expansion, and then for the tiny remainder that makes it all the way here, we lose most of what's left. Simply by living the way we live. There's a counterpoint worth including here, too, because it's not all bleak, and it makes the whole picture stranger rather than simpler. In recent years, a space telescope named after physicist James Webb has managed to capture light from some of the earliest galaxies that ever formed, light that has been traveling 6 billion years of that journey. It's a genuinely remarkable achievement, and it's tempting to read it as proof that the universe does eventually get witnessed after all that for over 13 billion years, nearly the entire age of the universe, just to finally land on a mirror built by a species that didn't exist for the first 13 patients in technology are enough to close the gap. But even that triumphant story only underlines the scale of everything else being described here. That telescope caught a vanishingly small number of individual points of ancient light, chosen carefully, aimed deliberately, requiring the accumulated engineering effort of an entire species just to intercept a fraction of what? A single ancient galaxy actually emitted across its entire existence. For every photon captured that way, staggering, almost unthinkable numbers, more from that same galaxy released in every other direction, over billions of years never had any chance of being caught by anyone ever, no matter how advanced the civilization waiting on the other end might have been. Now, let's zoom back into something closer to home, because the waste isn't only a story about the extreme edges of space-time. It's happening right now in your own galaxy, and nothing will ever intercept it. Picture our own sun for a moment. Earth receives a genuinely tiny sliver of the sun's total energy output. Current estimates put it at scales you'd never think to question. Even stars, close enough that their light easily reaches Earth, are still radiating the overwhelming majority of their total output into directions where absolutely roughly 2 billionths of everything the sun produces. The rest radiates outward into every other direction across the solar system and beyond into interstellar space, mostly toward nothing at all forever. And our sun is, relatively speaking, a star with an unusually attentive audience. It has 8 planets, at least, one of which is definitely watching. Most stars in the galaxy don't have that. Countless stars are drifting through interstellar space entirely, alone, without even a planetary system to catch even that infinite decimal fraction. Their light expands outward into a universe with nothing nearby to receive even the accidental crumb that Earth receives from the sun. Astronomers even have a name for this category of star: rogue stars ejected from their original galaxies by gravitational interactions and left drifting through the vast emptiness between galaxies entirely alone with the nearest planet. if one exists at all, potentially light years or even light centuries away. Every photon such a star produces has, statistically, almost no chance of ever crossing paths with anything at all for the entire remaining lifespan of that star, which for smaller, longer lived stars can stretch into the trillions of years. There's also a stranger, quieter form of this same waste happening to light that does technically reach us, but arrives so faint, so stretched, and so degraded by the journey that it might as well not have. As light travels across billions of years and billions of light years, the expansion of space stretches its wavelength longer and longer. A phenomenon called redshift. Light that started out as blazing visible light from a young, brilliant galaxy can, by the time it reaches us, be stretched so far into the infrared or microwave range that is completely invisible to the human eye and detectable only with specialized instruments built specifically to catch what's left of it. In a very real sense, most of the ancient universe isn't dark because nothing shines there. It's dark because the light that once blazed there has been stretched into a form we simply aren't built to perceive without help, arriving not as light anymore, but as a faint, cold echo of light, a whisper of something that used to shout. So here's the full shape of it laid out. Together, a universe containing something in the neighborhood of a trillion stars, each one radiating impossible for anyone to ever witness, not due to any limitation of technology, but due to the basic geometry of an accelerating universe, a horizon that is actively shrinking the visible portion of the cosmos for every future observer, guaranteeing that whatever anyone sees tomorrow will be strictly less than what we can see today. And even within the light that does arrive, an ongoing process of stretching and fading that quietly erases most of it into forms we're not equipped to perceive without specialized help. If a mind built this on purpose, intending a universe that would be seen, marveled at, and understood, the actual physics reads almost like the opposite. Instruction, it reads like a system, engineered, whether by accident or by design, to guarantee that witnessing is the overwhelming exception, and darkness, in every sense of the word, is the default outcome for nearly everything the universe ever produces. There's a fair objection worth raising here, the same way it's fair to raise it about any argument like this one. Maybe light was never meant to be witnessed at all. Maybe its purpose, if it has one, is simply to exist, to carry energy outward, to be part of the physical process of a universe running exactly as designed, regardless of whether any eye ever intercepts it. Value on this view doesn't require an audience. A sunset is not less beautiful on a planet with no one home to see it. That's a genuinely thoughtful response, and it deserves to be taken seriously rather than waved away. But it also quietly concedes the entire point being raised here. If light doesn't need to be witnessed to have value, then the countless religious and philosophical traditions that describe a universe as something built to reveal a creator's glory, to be marveled at, to serve as evidence of design meant to be recognized, are describing a purpose that the actual physics of light distribution makes almost impossible to fulfill at any meaningful scale. You can keep the idea that light has inherent worth independent of being seen, but you can't keep that idea and also keep the idea that the universe was built as a grand display meant for an audience. The physics only really supports one of those two claims, and it isn't the one about being watched. Maybe there's a reason for that we simply aren't equipped to see from our vantage point. Maybe the value of that light was never in being witnessed at all, and the assumption that creation exists to be seen says more about how we think than about how the universe actually works. Or maybe the honest reading is simpler and colder than that. That light in this Universe was never made for an audience in the first place, and the tiny sliver we happen to catch isn't evidence of purpose. It's evidence of nothing more than geometry occasionally, briefly, accidentally lining up in our favor. Either way, tonight when you look up and find a single star bright enough to notice, remember what you're actually looking at. Out of everything that star has ever produced across its entire existence, you are catching a fraction so small it barely deserves the word fraction, and everything else it has ever sent out into the dark is still traveling right now toward absolutely no one and always will be, and here's the last thought worth carrying with you after this ends, somewhere out past the edge of what any telescope will ever reach, past the cosmic horizon that is already sealed off. 3 galaxies we'll never even know existed. There is light traveling right now that left its source before Earth had formed, before the sun had formed, in some cases, before most of the elements that make up your own body had even finished being forged inside older, longer dead stars. That light is not waiting for you. It was never going to reach you, and it never will. It simply exists, moving outward at the only speed light is allowed to move, indifferent to whether the story of a universe was ever supposed to include a witness at all. If that indifference troubles you, sit with it for a moment rather than rushing past it. And if it doesn't, ask yourself, honestly, whether that's because you found real peace with it, or because, like almost everyone else looking up at the same sky, you simply haven't let the number sink in